Looks like we have our work cut out for us on this one. We have division, which means we need to keep this fraction the way it is, change this to multiplication, and flip that over. Some people call it keep, change, flip. I don't necessarily, but it is that idea, if that's how you learned it. And we also have some factoring to do. So not to confuse you, but I want to do more than one step at a time because, well, we're adults. So I'm going to do... This one's going to get factored and not mathematical wording, but flipped over. So we're going to reciprocate that one. And just looking ahead, this doesn't factor. So there it is. Again, it was in the bottom, now it's in the numerator. The bottom becomes the numerator when you flip it over. Man, mixing up my mathematical wording. The denominator becomes the numerator. Let's move on. GCF over here, 6y. That gives me y plus 7. Okay. Factor that one. Now again, I really, I say it again, it's the first time I've said it in this video, please try this on your own. Like if you're like, man, I'm totally lost, watch it, sure. If you know what you're doing, mute me. I wish you could do that in real life. Mute me, try it on your own. Why? Because I said so. Two numbers multiplied to give me 70, must be 7 and 10. Okay, no GCF there. Two numbers multiplied to give me 72. They are negative 72. So I need two opposite signs. So 9 times 8. Negative 8 times positive 9 gives me negative 72. Negative 8 plus 9 gives me positive 1. We're ready to cancel some things out. We can cancel things out within the individual fractions and also outside the fractions. And that is all. That's all I can do. This 6y does not cancel with anything over here. I wish it did, but I'm sorry it doesn't. You can't reduce the 6 with either of the y's. You can't reduce the 6 with the 9 or the 8 because this is a factor. 6 is a factor, y is a factor, and then these individual things are factors. So we will put 6y, y plus 9, y minus 8. Okay, let's go to the next one. Just waiting for us over here. We're going to represent this one a little bit differently. This is a fraction divided by a fraction, which is a lot of fun, but I'm going to write it the way we just wrote the previous problem, which was a fraction divided by a fraction. So, same thing. Fraction divided by fraction. And now it looks like what we just saw. So if you don't find it necessary to write this step, feel free to skip this step, but it helped me bridge the gap to the next step, which is this. Now, let's talk about that negative. That negative is in front of a fraction. The whole fraction is negative, which means either the numerator was negative or the denominator was negative, but not both. Does it matter which one you give it to? No. I'm just going to throw them up there. Okay. For example, if I said, I have negative 1/2, okay, do you have negative 1/2? Do you have 1 over negative 2? Or do you have negative in the front? Yeah, all the same thing. It doesn't matter. Doesn't matter how you slice it. It's still the same birthday cake. Okay. Why birthday cake? I don't know. So what we're going to do is multiply if we can. We're going to cancel if we can, but we can't cancel anything. Good luck. Yeah, cancel the 1 with that 1. Don't do that. Don't you dare. I know a guy that tried that. It didn't work. So we just have a sloppy mess where nothing cancels. We have x. That's a 10. We have a negative 10 and then an x minus 1. And then here we have 2x minus 7 times 1. So 2x minus 7. And that's it. That's all we can do with that one. Let's jump to the next one. There. We jumped to the next one. That was a bad joke. 3x cubed over 10 divided by 6 over 5x cubed. Skip this step if you like, because I recommend that you jump straight to the next step. When you look at this and you say, why don't I just multiply by the reciprocal? It's kind of how I draw it in my head. Keep this one, but then take this one and flip it up. So we're going to have 3x cubed over 10. Nothing factors here, really. I mean, you could be like, oh, that's 2 times 5, but you don't. Unless you really want to. Okay. This is going to be a disappointing problem because it looks like those x cubes would cancel. They don't because they end up both in the numerator, so they're not going to cancel. So we're going to have, let's see, 3 goes into itself 1 time, 3 goes into 6 2 times, 5 goes into itself once, 5 goes into 10 twice. And I'll cancel the x cubes. No, they're both in the numerator, so don't do that. I'll cancel the 2's. No, they're both in the denominator, so you can't do that. Please don't try it. Not worth it. 1 times x cubed times 1 times x cubed is x to the, oh, is it 3 plus 3? Is it 3 times 3? I'm glad you asked. If I have x cubed and I multiply by x cubed, there are 6 of them. Just refreshing your memory. And then I have 2 times 2, so it's that.